Good afternoon, everybody. How are we doing? Can you see me? Can you see me? Everything okay? Hello, everyone. How are you doing? Welcome to this week's stream. I am Yusuf, as always. Welcome to Squads with myself, where we learn a bit of mathematics to do, as you progress in your GCSEs or whatever stage of your education you're at. I hope you're all doing fantastically well. Hope you're having a splendid week. If you're a regular, welcome back to the stream. I see Mikhail in the chat already. He's a regular. Thank you for tuning in, Mikhail. Hope you're well. The rest of you, feel free to message in the chat as well. Okay, welcome to the stream. We chill, we relax, we do some work, we have some fun because we're a team. And it's all about collaboration and making progress. Okay, so as you've probably already seen, the focus of today, guys, is going to be on recurring decimals. Okay, it's 5 past now, so we might give a couple of minutes just for the rest, or if there are any others to come in. But that is going to be the focus of today. But what I do want to get you
thinking about... I didn't get that. Could you try again?
Shut up, Siri. Sorry. Shut you up. Right, recurring theme series back again. In terms of recurring decimals, then, can any of you guys in the chat, can you maybe think about what a recurring decimal is? If I asked you to describe to me what recurring decimals are, how would you describe them? Okay, that is something for you to think about. If you want to give an answer in the chat, please do. Other than that, we'll just hang around for a bit, maybe 2-3 minutes before we actually get going. And just chat a little. How's everyone been? Okay, how's everyone's week been? I know it's been slightly cooler where I am, so I hope it's the same with you guys. Enjoying the weather, but it's not too warm. Everything's fresh. Everything's cool in that regard. Okay, so tell me how's your week been? I mean, to be honest, I've been a bit lazy this week. I can't lie. I've been watching the cricket. I don't know if we've got any cricket fans. Anyone here tuning into the Ashes? It's pretty intense at the moment. Okay, I don't know what's happening as of right now, but last time I was watching that England were on the right path to hopefully getting the victory. So if any cricket fans are in the chat, fingers crossed we can get over the line today. Okay. Anything else, guys? Tell me about how you've been. How's everything? Hey, Inga, thank you so much for joining. Inga, our perfect and our very amazing moderator, is in the chat as well. Hope everything is well with you. All right. I think as I said, we'll give it 2 minutes. We'll start at about 10 past, and then we'll sort of progress with that. Okay. So 2 more minutes. Tell me, guys, Mikhail, how have you been? Yeah. So you've been good, fantastic. How's school? How's school? Is it? Hope it's a bit easier now that the weather's slightly cooler. What you been up to? What you guys been doing? I know it's sort of nearing the end of term right now. I know you've got still a couple of weeks, but it's that last term, right, where you feel a bit, you're like, I just want to get over the line because I'm nearly at summer holidays, but at the same time, it's just so close, or you just want to relax as well. So, how's that been? Okay, tell me how it's going, and how you all are doing. Okay, a couple people are coming into the chat as well. Welcome to the video, guys, or to the stream. My name's Yusuf. If you're new, thank you so much for joining. Hopefully, you'll learn something new today. If you're a regular, how you doing, man? Hope you're doing fantastically well. Okay, right. So hopefully you guys are having a think about what recurring decimals are as well. Okay, in terms of a description, what we think about when describing recurring decimals are, obviously they have to be decimals in terms of the type of number, but the recurring bit refers to a set of numbers that repeat an infinite amount of times. Okay, so hopefully you guys understand what that means. You probably have an idea in terms of what recurring decimals are, but in terms of a descriptive understanding, that is how I would like you to describe it. Okay. End of year test. Ooh, it is that time where it's a bit intense with the tests as well. I hope they're all going well, guys. I respect you guys, the utmost respect for you guys. It is a difficult time, especially end of year, because of the fact that you're so near to those summer holidays, but at the same time, you've got that big final hurdle of things like end of year exams, mocks, whatever you're doing. So, keep at it, guys. one final push, and then you can relax, you can chill, you can do whatever you want. Okay. I always say to my students, when you have that 6 weeks off, or however long you have off, do whatever the hell you want, right? Because you've earned those 6 weeks. So if you want to be as lazy as you want, okay? Be as proactive as you want, be as productive as you want, but at the same time, take some time to relax as well, because you've earned the time to rest. So make full use out of it. Okay. Okay. What we'll do then is we'll get going, and we'll just make a start on recurring decimals. So in terms of what you guys need to know for the specification when it comes to recurring decimals, the main thing is converting recurring decimals to fractions. Okay, it's pretty straightforward if you think about it, and hopefully you guys see why that is. But all you have to do is you just have to be able to adopt a pretty basic, straightforward method, and then alter it for 3 different types of scenarios. Okay, we're going to go through each of those scenarios. So like I said, there's 3 scenarios, and we'll go through each of them, do a couple practice questions, exercise questions, and then I do have a very, I want to say challenging, I have a high level exam question that I want us to do at the end as well. So stay tuned for that, because, if you feel like this is all fairly straightforward and elementary and you guys can understand it, then you will definitely want to stay around for the exam question at the end. Okay, let's move over to the learning screen then. Okay, right. Hope you guys can see this. Let me know. Give me a thumbs up. Give me a thumbs up in the chat if everything's okay. Also, let me know if everything's crisp and clear as well, because I have tried to alter the settings to try and make it a bit more high definition, but I might have done a stupid thing and possibly made it worse. So if some bits are not clear or you can't really see some things, I'll try and zoom in. Okay, right. So recurring decimals, as I was saying, and what we are going to do. So as I said, there's 3 types of situations, or 3 scenarios that you need to be able to convert recurring decimals to fractions. And the first one is here. Let me just alter that. Yes. So the first type of situation or scenario in which we are required to convert recurring decimals to fractions is if there is only one recurring number. Okay, what do I mean by one recurring number? Well, it's pretty straightforward, hopefully, if you can see it, right? The only number that is recurring is 5. So that means that there is one recurring number, okay? So what do we do when trying to convert this type of number into a fraction? So first things first, what I want you to do is I just want you to rewrite this whole decimal, or this number, or recurring decimal, and equate it to x. That's the first thing we're going to do. So that's pretty straightforward. Okay, that's the first step for all types of scenarios. You just write the same decimal and equate it. You can equate it to anything. X, Y, Z, A, B, C, D, whatever you want. Okay, that's not important. Just equate it to some sort of variable. Right. When there is one recurring number in your decimal, the key thing is, the thing that distinguishes this method from all others is the following. You multiply, okay, you have to multiply by 10 in this situation. So if x is equal to 0.5 recurring, then if we multiply this by 10, we'll obviously have 10x. Okay, and I'm intentionally writing it, sorry, let me just write it a bit clearer. I'm intentionally writing it above the original value of x, and you'll see why that is the case shortly. Right, if we multiply anything by 10, we know everything shifts one place value to the left, so we end up with 5.5 recurring. Okay. Right, so what happens now? You'll see why, so the reason why I put the 10x above is because the next step of this process is actually a subtraction. So you subtract the 2 values that you've created. And when you subtract them, you'll quickly realize that every number here lines up perfectly, which means if you were to subtract them, they cancel each other out, obviously up until this point. So what you're really left with is 5 minus 0, right? Because all the numbers beyond the decimal point, they just cancel each other out. So they cancel out, okay? And so we are left with 5 minus 0, which is 5, right? And obviously, because it's an equation and we're subtracting, we're going to have to subtract the 10x and the x as well, in which case we have 9x. Okay. For those of you wondering, it won't always be 0 that you subtract here. It's just this particular example. Don't worry about that. But yeah, it won't always be 0. It could be a different number in which you have to actually do a subtraction. But you know, this was relatively straightforward. Yes, and as Finn has correctly identified in the chat, then all you have to do is you just have to solve for x. If 9 times x is equal to 5, then what is x? Well, you'd have to just divide 5 by 9 to get x on its own. Okay, so once you get to this stage here, where you have 9x equal to 5 or whatever it is you're dealing with, then you're pretty much done. What it is then about is just some bit of algebraic manipulation. Okay, and if you're tight, if you're good, if you're confident with algebra, then you know you'll have no problems there. Okay, yes. So thank you, Finn. The answer would indeed be 5/9 for this, right? And you can actually verify this, right? If you guys have a calculator, if you've got a calculator with you, if you type in the fraction 5/9, and then you press SD, you will actually get 0.5 recurring as a decimal. Okay, which is nice. So you can kind of verify if you get the right answer with these types of things, right? Another thing you might be wondering, does this come up on a non-calculator? Does it come up on a calculator? To be honest, because you can verify if you've got the right answer on a calculator, it is more likely to come up on a non-calculator in my opinion. But having said that, I have seen it come up on a calculator paper. For the students who took GCSEs this year, this actually came up in their paper 3, which is a non-calculator. Okay, but obviously to get all the marks, you have to show this level of working out. Okay, so you have to show x originally, then you multiply it by 10 or whatever, and then show the subtraction. That's how you get the marks. If you literally if your answer looks like it's come from a calculator, then you might not get all the marks, if that makes sense. Okay, perfect. Right. Give you a couple of seconds just to get all this down. Hopefully you understand everything. Everything's relatively straightforward. Let me know if you guys have any questions. Let's move on to the next one. Okay, yeah, so I've put this as for you guys to have your turn, or for you guys to have an attempt. Okay, similar type of question now, but instead of it being 0.5 recurring, it's 0.1 recurring. So the number that's recurring this time is 1. But since there's only one recurring number, the method is still the same. The method is still the same in that you write the recurring decimal as is equal to x, and then you multiply it by 10. Do the subtraction, so 10x minus x, and then whatever you have as your numbers, subtraction as well. And then once you get to that stage, it's just a case of solving in terms of x. Okay. Some of you have put the answers in the chat already. Thank you so much. Well done, guys. I love the speed. Really, really good. But we're just going to give time for everyone else to catch up as well. Okay. And then we'll move on. Okay. I think, to be honest, this is relatively straightforward. I do want to have a go at some of the other more challenging questions. So this is the only one that I'll get us to practice, and then we'll move on to the higher level stuff. Okay. Or the more challenging stuff. Yes. So what I'll do is I'll quickly show you what you should have done. Okay, so as always, we start by equating it to x, and we write it out like this. Because it's one recurring number, guys, we're going to times it by 10. So 10x is 1.1111, blah, 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 blah. We carry out our subtraction. 10x minus x is 9x. All of these cancel out when subtracting. And so you're left with 1 minus 0, which is 1. And so x is equal to 1/9, as Finn and Mikhail correctly put in the chat. Thank you so much, guys. Okay, not overly complicated. All right, this is relatively straightforward stuff. How does it get more complicated? Well, I'll show you now. Okay, this was another example, but I don't think I need you guys to have a go at this, because it's the same thing, but it's just given in a different notation. Just remember, when you have something like this with a dot on top, it's just referring to that number recurring over an infinite period of time. Okay, so this is just 0.222222222. The reason why I put this on is just because I wanted you to be comfortable with that different notation. But don't worry, you don't have to do this one. We'll skip it and move on to the next one. Okay, thank you, Mikhail. I knew one quick-witted person would put the answer in the chat anyway. Thank you so much. Okay, so what do you do when you have two recurring numbers? Okay, so the thing that distinguishes this from the other question, or when you have one recurring number, is instead of multiplying by 10 this time, you're multiplying by 100. Okay, so if there's one recurring number, you times by 10. If there's two recurring numbers, you times by 100. Okay, and then you can probably guess what we do when we have three recurring numbers. Okay, so similar thing, 0.121212, blah, 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 blah. Okay, as I mentioned, this time we're going to times by 100. So we have 100x is equal to, and because we're timesing by 100, everything is going to shift 2 places to the left. So this time we end up with 12.121212, blah, 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 blah. Okay. And for some of you, you can probably now realize why we multiply by 100. Because if we say, for instance, multiplied by 10, the numbers here wouldn't line up perfectly. So we always want to get to a stage where the numbers do line up in exactly the way we want to, so that they can cancel each other out. Okay, if you don't end up with that situation, more often than not, then you've done something wrong. Again, we're going to carry out our subtraction. Okay, we have all of these that cancel out. And so we are left with 12 minus 0 again. So we have 99x is equal to 12 minus 0, which is 12. Okay. And then, as we did last time, we can just divide and get x like so. Okay. Now, some of you might be wondering, do we need to simplify this fraction? That is an excellent question if you thought, simplify the fraction. Excellent question if you're thinking about it. And my answer to that would be, only do so if it specifies in the question. I mean, I know teachers have taught over a series of, whatever school you're at. The general rule of thumb is just simplify anyway to be safe. Okay. Which is a good idea. If you want to, that's fine. But I would say, if it doesn't specify in these types of questions, you don't need to. If it says given in its simplest form, then obviously you would have to. Yes, thank you so much, Finn. Yes, you would realize that both of these numbers are a multiple of 3. So they come up in the 3 times table. So if you divide both the top and bottom by 3, we actually end up with 4/33. Okay, and again, my personal opinion is, they might ask you to simplify it, and it probably will be worth an extra mark, especially if it's on a non-calculator, because obviously you might be dealing with some bigger numbers, in which case it might take a bit longer to simplify. Okay, hopefully that makes sense. I'm not seeing any questions in the chat, so that hopefully means that it's resonating well with you guys. Oops, not this one. Yes, have a go at this thing, guys. 0.36363636, blah, 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 recurring. Okay, how can we convert this into a fraction? Right, because we have 2 numbers recurring this time. Not only is it 3, it's also 6 that's recurring. So we're going to multiply by, not 10. Okay, that's the hint I'm going to give you. We're going to multiply by 100. Okay, so we multiply by 100. Do your subtractions, and I'll give you some time. Yes. Okay, and then once you have your answers, let me know what you get. We'll discuss them in a short while. Yeah, I'll give you maybe a minute more. I know we're going through things a bit relatively quicker this week, but it's just because I think that once you sort of get this method, it's really nice and straightforward because you can apply it quickly. And generally speaking, I've seen questions that at least they'll give you 3 marks. I have seen some 4 markers on this, but the 4 or 5 markers tend to have something extra at the end. And I'll show you an example of that at the end. So that's something that comes up in the exam question as well. Okay, brilliant, looking good, guys, perfect. Okay, answers in the chat are coming in, which is really, really good. I see a simplified answer as well, which is fantastic. Okay, so let's quickly double check. This is what we should have got. Okay, blah, 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 blah. And again, we're timed by 100. So we have 36.363636. 3, 6, blah, 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 blah. These cancel out. Nice. And straightforward. So we're left with 99x. Sorry, we're going to do our subtraction. So we're left with 99x is equal to 36. Have I done that right? Yeah, sounds right. And then x is equal to 36 over 99. Yep, perfect. Have I done that correctly? I feel like I might have. Yeah, yes. This is what you guys got in the chat as well. Well done. 4 over 11. Brilliant. Yeah, because you can divide them both by 9. So yeah, 4 over 11 is the correct one. Okay, perfect. Really, really nice. What time are we on? Okay, we're actually doing really, really well for time. So, let's move on to when we have 3 recurring numbers. And again, like I said, intuitively, I'm guessing you already know what we multiply by this time. Okay, what do you think we multiply by this time, guys? 1,000, yes, well done. So once we multiply by 1,000, everything shifts how many places to the left? 3 places to the left. Okay, so we're actually going to end up with 125.125, 125, blah, 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 blah. They cancel out. Okay, sorry, I know I'm going a bit quicker than before, but yeah, they cancel out because we're going to do the subtraction, obviously. Once you subtract 1,000x from x from 1,000x, you end up with 999x, and then this is just 125. Okay. Good, lovely. Yes, we can simplify this or solve this, sorry, by just dividing by 999. Perfect. I don't know if these can be simplified actually. Can they be simplified? They might be able to be simplified. I'm not too sure. We're not going to, but if you guys want to do that, definitely have a go, have a try. But I don't think they can be simplified. Yeah, don't know. Might be. Don't hold me on that. Okay, so, and that is that. Essentially, we're done. You go 3 marks. Like I said, typically 3 marks is what you would get for this type of question. So if you can remember this, okay, just remember you're timesing by 10, 100, or 1,000, depending on the amount of recurring numbers. Then you do a subtraction, and then you are solving it algebraically, right? So there's nothing that there's nothing that's over strenuous to remember, other than the fact that you have to multiply depending on how many recurring numbers there are. Okay, hopefully that makes sense. Okay, let's see where we are at. Obviously, I want you guys to have a go as well, right? This is the one I want you to have a go at. Let's see. Yeah, so there's two more questions, and then the challenge exam question is nearing as well. Okay. Yeah, I know for typical streams for the last 2-3 weeks, we have been going for a lot longer, but this time the lesson will probably stem for about 40 minutes, 45 minutes, and then because I want to leave some time at the end for you guys to ask me questions. I feel as though sometimes I'm doing a bit too much talking, a bit too much teaching, and not giving you guys giving you the chance to speak and ask some questions as well. Okay. Okay, right. Wow, that is spectacular speed. Well done, Mikhail. Yeah, I haven't worked it out myself, so I can't verify if it's right or not, but it seems correct. Okay, so I am interested in the method as well, guys. Like I said, especially if this comes up on a non-calculator, if you give the answer, obviously I trust that you guys have done the correct method, but if you just give the answer and no working out, it is 100%. It's not likely, it's definite that you won't get full marks, because they're not interested in just the correct answer, they're interested in also if you're aware of the method. Okay, primarily because of the fact that some students, well, you can obtain the correct answer to this by simply putting into your calculator. Hope that makes sense. Yeah. Brilliant. So yes, x is equal to 0.621621 blah 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 blah, times in it by 1,000, we end up with 621.621,621 blah 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 blah. Okay, and subtract the 2, we're left with 999x is equal to, all of these cancel. 621 minus 0 is just 621. x is equal to 621 divided by 999. And that is that. Okay, perfect. Right, tell me then, guys, do you want to have a go at a question, another question similar to the one you've just done, or shall we just jump straight in to the challenge exam question? What do you guys think? Because we can have a go at another, but I think you guys are doing relatively well. You've picked it up fantastically, which is brilliant. I do have another one here, but in all honesty, I'm happy for us to skip this and go straight to the exam question. So, what do you guys think? I mean, we're doing well for time, so we might as well do this. Okay. Just take a couple of minutes. Right, Mikhail's saying challenge exam question, so now I'm feeling tempted to just skip this. What? Anyone else feel like they want to do the challenge exam question? Yeah. Okay. Okay. Yeah. So for those of you who want to do this, have a go. Thankfully, Mikhail and Finn have put the correct answer in the chat below. So if you want to have a go at this, do this first, and then catch up with us on the challenge exam question. Okay. But what we're gonna do is we're gonna skip this. Yeah. Thanks, guys. No worries. Okay. Here is the exam question. I'm actually gonna zoom in to this bit here, and here it is. Okay. So this was a question that came up. So it's not from an actual exam paper. This is from a predicted paper, I think. It's from a predicted paper of this year's stuff. So I am intrigued. I don't want you guys to have a go at it because I do feel it's quite challenging. Give me your thoughts in terms of how you would feel we would go about answering this. Okay. Lil JR XYZ, how you doing, man? Thank you for joining. Hope you're well. Okay, thank you for joining. Better late than never. What we're doing today is recurring decimals. So if you are feeling like you need to have some work, well, fair enough, man. Well, you know what? Hopefully you can gather something from this from the last 5 or so minutes. Okay, the rest of you, what do you think? Okay, I'm just gonna stay quiet for 2 minutes because I'm interested in seeing how you would go about. Because when I say challenging, I did mean challenge. This is a very high level question, and as you can see, it's worth 4 marks as well. And I believe this was a calculator question, right? So meaning that it is on a calculator paper. Okay, but that doesn't mean you can simply put this into a calculator and get the answer. You have to, because it says, I mean, it's specified here, using algebra. That's the key thing. Okay, use algebra to prove that 0.53 recurring with, so the dot is just on the 3, so only the 3 is recurring, and 0.16 only the 6 is recurring. Okay, that when you divide the bigger one by the smaller one, show that we end up with 3 1/5. Okay, right. Is it laggy? Oh, I do apologize, guys, if it's laggy. That's a shame. Does it really? I'm just checking now. Oh yeah. I do apologize. I don't know why that's happened. Apologize, guys. I'll try and get that fixed for next week. Yeah, that doesn't look great. Sorry, I had the stream open on this side. I didn't really look at my face. Yeah, we'll get that fixed. I'm so sorry. I do apologize, guys. Okay. Right. Hopefully you guys have an attempt on the exam question. And I'll show you now. Okay, I will begin now. Right. So essentially what we are doing is, in order to answer this question, we are converting each of these to fractions first. Once you convert them to fractions, you do the division with the fractions. Okay, so I'll show you what I mean by that. So for now, we're going to isolate the two numbers. So we have 0.53 recurring. Let me just make my pen a little smaller, a little thinner. Okay, so we have 0.53 recurring. Okay, so let's focus on that first. That would be 0.5, and then we have 3, 3, 3, 3, 3, like that, dot, 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 dot. Okay, because there is one recurring number, we times by 10. So 10x is equal to 5.33, oops, 3, 3, 3, 3, blah, 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 dot, 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 dot. Okay. Right, and then we carry out our subtraction. Okay, 10x minus x, that leaves us with 9x. Then all of these cancel out. Okay, notice how this time everything, so the 3's cancel out, but not everything. We're still left with 5.3 minus 0.5. Okay, so what would you do here? Well, obviously it's just a decimal subtraction. You probably already know how to do that. It's relatively straightforward. But as I mentioned, it's on a calculator paper anyway. So just to be safe, you can use a calculator to answer this. So 5.3 minus 0.5 is actually 4.8. So that is what you end up with here. Okay. So x is equal to, have I done that correctly? 5.3 minus 0.5. Yes, sounds right. 4.8 over 9 is your answer for this. But what do we not like about this? We don't like the fact that we have a decimal in a fraction. So how do we get rid of the decimal in the fraction? We just times everything by 10. So what this really becomes is 48 over 90. Okay, and at this stage, we can simplify because both of these can be divided by 6, I believe. So 48 divided by 6 is 8. 90 divided by 6 is 15. Yeah, so that is for that. Okay. And then you want to do the same thing. You want to do the same thing for the other fraction, the other recurring decimal. So I'm going to do so using a different color. Let's use blue for that. So we have 0.16 recurring. Let me equate it to x. So x is equal to 0.16 recurring, like that. Okay. I'm seeing some answers in the chat as well. That is absolutely fantastic. Then this becomes 1.66666, like that. We're going to do our subtraction, so all of these cancel out, and we're left with 1.6 minus 0.1. Okay, and that just leaves us with 1.5. And over here we have 9x, and so if we solve for x, we have 1.5 over 9. Have I done that correctly, guys? Have I done that correctly? Yeah, I think I've done that correctly. And the only thing is, we want to get rid of the decimal, so this becomes 15 over 90. Okay, and again, you can simplify this. I believe this is 1 over 6. Right, have I done that right, guys? Is this what you got? 1 over 6? Let me see. Right. Okay. Mikhail, you got a different answer, so let me just double check. Like I said, because this is a calculator paper, yeah, it should have been 1 over 6, Mikhail, so double check the one that you got. I think you might have just made one small intricate detail or one small intricate mistake. Okay, so, but the important thing is, guys, that we end up with this. We end up with 8 over 15 and 1 over 6 as the final two fractions, okay? So if we think about what we had originally in the question, okay, 0.53 recurring divided by 0.16 recurring. If we rewrite that now, but as fractions, we can actually solve it. So we have 0.53 was 8 over 15. Okay, so actually what I'm going to do is I'm going to rewrite the whole thing. Let me just change back. Let's do green this time. So 0.53 recurring divided by 0.16 recurring is equal to 8 over 15 divided by 1 over 6. Okay. And now it's just a case of dividing fractions. Okay, now again, because it's an exam question, it is very likely that they'll combine different aspects of the syllabus together and ask you and expect you to answer a question. In this particular question, they're expecting you to be able to convert a recurring decimal to a fraction, and also sorry guys, I just realized my camera is messing. Okay, is this better? So this is what you should have ended up with. Hopefully, yeah, I've zoomed out a bit. So yeah, they're expecting you to convert recurring decimals to fractions, and also thank you for Mikhail for pointing that out as well. And so they also expect you to be able to divide fractions. For those of you who know how to divide fractions, hopefully you're thinking about something along the lines of KCF. Okay, what is KCF? KCF is a mnemonic that we use to divide fractions, which basically is synonymous with keep, change, flip. So you keep this first fraction the same, you change the divide to multiply, and you flip the second fraction. So what this actually becomes is 8 over 15 multiplied by 6 over 1. Okay, 6 over 1. Multiplying fractions is relatively straightforward. You multiply the numerators, multiply the denominators, and so we'll do that. 8 times 6 gives us 48. 15 times 1 is 15. Okay, perfect. Thank you, Mikhail. That is the correct answer, 48 over 15. But the final thing we have to do is just convert this from a top-heavy fraction to a mixed number, because that's what I wanted in the question. Okay, so this is going to be 3 and 3 over 15. Okay, but if we just consider 3 over 15, well, 3 over 15 is the fraction that can be simplified to 3 and 1/5, which is what the question wanted. Show that or prove that if you divide these two numbers, you end up with 3 and 1/5, which is what we ended up with. So hopefully you guys can see how we got that. Okay. Any questions? I know I do apologize. I know that I was covering the question a bit. My bad, guys. My big fat face was in the way. But I hopefully you can see it all now. Hopefully you can also understand each bit of the working out. Okay, so this was the bit in red was the first thing that we did. Then the bit in blue was the second thing that we did. Then the bit in yellow was the final step. Okay, and the final few marks. My guess is, in terms of the marks, they would give you, if you converted both recurring decimals to fractions correctly using the methods that that are on the board right now, then you'd get 3 of the 4 marks. Okay, the last mark actually comes from you being able to recognize or divide fractions using KCF. Okay, which means when you divide fractions, keep this first one the same, change the sign, flip the second fraction, and then that is how we end up with this. Okay, another exam style question. I don't have one. I'm so sorry, Mikhail. What I can try and do is I'll try and fetch you one, okay, but for the time being we've finished anyway. So I mean the last 10 or so minutes, guys, are allocated to you guys to ask me questions. Okay, so if you have any questions in regards to anything that you're doing in school, your mathematics or another topic, also if you have any suggestions as to what you would like us to cover next week, let me know as well. Okay, in the meantime, I'm going to fetch another exam style question for you, Mikhail. Obviously, we won't have time, probably won't have time to go through it, but I'll try and give that to you anyway. Okay, if I can find one. So yeah, other than that, guys, that is recurring decimals in a nutshell. Okay, so if you understood everything, then you should hopefully have no problems when if it comes up in your exam. Okay. Any other questions, guys, before we start wrapping things up? Let me know if you have any questions. So to do with anything to do with maths, to do with exam etiquettes or revision techniques, anything like that, I'm happy to. Okay, perfect. Thanks, Finn. Yeah, what I would do is there are actually, if you go into, so my advice would be for, if you're looking for paper 1, paper 2, there is a resource called, I can't even remember what it's called now. Okay, actually, let me see. I might have a copy of it here somewhere. Finn, this is for you. If you have maths mocks coming up, guys, what I'm actually going to do is I'm going to show you something. 1 second. Okay. Forgive me, I know it's taken a while, but have a look at this. Right. Finn, this is for you and anyone else who has maths paper 1 and paper 2 mocks coming up. Okay, so this, I would use this. This is a fantastic resource. Obviously, this is, yes, this one is actually called First Class Maths. And basically what it is, it's a breakdown of topics that have come up most likely on paper 1. Okay. Now, these are the most important paper 1 topics, right? So what I would do is I would look down the paper 1 column and I would look at the topics that are dark green, because they are the topics that are more often than not the ones that come up on paper 1, right? So we're considering things like index laws, algebraic fractions, probabilities, surds, proportionality, stuff like that. Okay, those, based on the last 6 years, I think this is, those are the topics that have come up most frequently on paper 1 topics. Paper 1 exams. So use those to build your revision, okay, and to sort of focus topics, okay, on what you would like to do. It gives you an idea on what to sort of focus on. If you're happy with these topics, then maybe move on to the lighter green ones and the yellow ones, so on and so forth. Okay, but this is a breakdown, so take a screenshot, take a picture, wherever you can, okay, of this. And this would, yes, of course. I'm not too sure if this paper is still available, but it might be. It's this resource here. It's called First Class Maths, and they have the same thing. So they have practice. These are practice papers, right? These were for the previous exams, but the same things apply, right? Because he's preparing them for paper 1 and paper 2 and paper 3 respectively. If you go onto First Class Maths, he's got a YouTube channel, he's got a website as well. All really good stuff. This person actually gives you a breakdown of things to prepare for in your various exams based on topics. Okay, so if you can use those as a basis of your revision, that will be a very, very good place to start off. Okay, I hope that helps Isla and Finn as well. Okay, if there's any other questions, so as you can see, this, if you want to have a go at this paper as well, you're more than welcome to. If you can read it, it says, this paper has been created based on the most common paper 1 topics from previous years. Due to the nature of some topics that are better suited to paper 1, as if they had a calculator, they would no longer be difficult to answer, blah, 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 blah. Okay, so essentially, this is for that, right? And obviously, as it says at the bottom, ultimately the best way to revise is to revise all topics. Okay, but if you're short on time, if you feel like you want to focus only on a select few based on research, and obviously this is a lot of statistics and research has gone into these topics, okay, and you can see why, because if something comes up 100% of the time on a paper 1, more often than not it's going to come up again, okay, but don't hold me accountable to that, but I hope that helps. So any other questions, guys, in terms of revisions, revision techniques, or just mocks in general? In terms, if there are any other tips, what can I suggest? Obviously, you use the same thing for paper 2 as well. See what topics come most often on paper 2, and that'll give you an idea. And then in terms of your revision, what resources are good? I think MathsWatch is good. If your school has a MathsWatch subscription, that is a really good resource to use in terms of revising topics. That was the case with me. They didn't tell us that we had a MathsWatch subscription. I actually asked them, and they're like, "Yeah, we have a MathsWatch subscription." I was like, "Come on, I didn't even know." So just by chance, I managed to get a full resource of MathsWatch stuff. Okay. Lil JR, I apologize, man. The timing's not set by myself. 4 to 5 on on a Tuesday. But obviously, because it's YouTube, the lesson's saved anyway, so you can tune in at a later time to watch it, just to make sure you're on track with everything that we covered. Okay. Any other questions, guys, before we head off? As always, you guys are an absolute treat. I love doing these streams. Okay, I get a bit nervous at times, not gonna lie, but you know, it makes it easier when you guys sort of communicate in the chat, and you're always fantastic. So thank you so much for that. Okay, especially the regulars. You guys are absolute legends. You know, I really appreciate all the things that you guys do and all the interactiveness that you bring to the lessons as well. Okay. Mikhail, yes, thank you so much, man. You're an absolute legend. Okay, if there are no more questions, we shall end it there. Also, let me know if you guys like the introduction tune. Okay, there's the song in the background. I feel like it's nice, not bad. It's got like a nice beat to it. But yeah, let me know how you feel about that. Now, Mikhail, you're too kind, man. No, honestly, did you know how they say your teacher is only as good as their students or their pupils? Honestly, that's the case. I'm only as good as you are. So if I'm the best, that means you are. So thank you so much, guys. You've been an absolute pleasure as always. Take care. You know, have an amazing rest of your week. I hope you have an amazing time at school, at home, wherever you are. Okay. Take care, guys. You're an absolute amazing bunch of students, and I hope to see you same time next week. I have been Yusuf. This has been Math Squads. I shall see you same time next week. Take care, guys. Bye.